It is one of the first things you'll see when booting up Doom, the melting screen. It truly is one of the most iconic screen transitions in the epic gaming world. But how does it work? First, let's check when exactly the melting screen occurs. In the intermission screen analysis video, we mentioned Doom having 4 game states. Whenever a game state changes, the game is told to play the melting animation. Let's visualize it when you finish a level. The game state goes from GS level to GS intermission. Doom's game loop compares its game state with the new game state. If it's different, then play the cool melting screen animation. But wait a minute, if you repeatedly start a new game, the game state never changes from GS level, but the screen still melts. How come? It's a bit of a hack when a new level is loaded. Here, a special variable is set to force a melt, or how Doom's source code calls it, a wipe. The same thing happens when the screen transitions from the episodic text to the ending image or cast sequence. Anyway, that's when the melting screen appears, but how does it work? First, we need to understand how Doom draws stuff on your screen. Doom uses 5 different frame buffers. A frame buffer is a data structure that contains visual data which then sent to the video system. The first frame buffer is used for mostly everything you see on the screen, while the other 4 are used for stuff like background and decreased screen sizes, the status bar, and the melting screen. One frame buffer is used for the melting screen's foreground, and the other one for the background. The transformed image is then written to the first frame buffer, which is then shown on your screen. While the melting animation plays, the game is placed in a forced substate where the game state is completely frozen. Now for the melting effect. The frame buffer is sliced into columns of 2 pixels wide. That is, Doom pixels, not your monitors. The title screen is 320 pixels wide, so 160 vertical slices are created. The initial slice gets a random offset between 0 and -15. The column after that, we use that offset as a base, but either +1, -1 or no change. This is done for the next column as well. This offset tells the slice how long it must wait before it starts moving down. Once the offset reaches 0, the slice will move down at a speed of 8 pixels per second. We can use wider slices to show this effect in action. Simply imagine a bunch of columns pushing down the slices from above. Once each slice is fully moved down, the game exits this frozen substate and the game is resumed. What's interesting is that the melting pattern is always the same. This is due to the sequential use of the RNG table. Here are 4 different intermission screen melts, and as you can see, the same pattern can be seen, just with a different horizontal offset. When you start a new game, the RNG table index will always be set to 0. Because of this, the screen melt when starting a new game will always be the same. On source ports that support higher resolutions, you can see the limitation of the RNG table. Because these do not use the hard-coded 320 pixel width, the pixels will be much smaller and in greater range. Here especially you can see the recurring pattern. So yeah, the melting screen is not that complicated, but it's cool to know how it works nonetheless. As always, thank you for sticking around, and a special thank you goes to the YouTube members and patrons, and a really big McThanky goes to the following extremely attractive turbo nerds: 19 Day, Agonizing Rectal Pain, Andrew Dunai, Andrew Riss, Andrew Yukimchuk, Andri Diklin, Art Cox, Bigsweg Mikum, Bitcore, Blue, Brian Thompson, Thunderstorm, Kappa Bitch, Chief Kotrake, Choose Your Fights, Cyprian Rusen, Circumcision Speedrunner, Francis T218, Vertac, Jace Dahlhover, John Guy, Joseph Shantz, Atsune Teku, Kirill Gorobets, Lars Soderberg, Matthew American, Matthias Sippert, Max Payne 67, Mr. Charan, Neko Ninja Core, Nighthawk 71, Pete Peterse, Pix Drift, Hiroshi, Quake Gamer 632, Raven King, Ryan Quinn, Richard Leahy, Riley, Robert Wakely, Salt Bad Guy, Sensodyne93, Space Duck, Specteer, Steak Jacobs, Stephen Bone, Steven Halustik, Teko Kami, Thomas, Tim Gerasimov, Tim Goldberg, Timothy Koller, Turbine2k5, Victor Rick, Who's Ace, and Zeb Rousdauer. See you in the next one.